Hello everyone. So today we are going to discuss about how will we find the zero force members in any truss. Okay. So the topic is identification of zero force members in truss. So there are two thumb rules to identify the zero forces in any truss. Okay. Now the first thumb rule number 1, which is if at any joint there are two members connected. Okay, if at any joint there are two members connected and at that joint there is no external force or reaction acting, then both the members will carry zero force. Like you can see here, if at any joint there are two members connected, then definitely if we take that joint, there will be two forces in those members. Like in one member there is F1 force and in the other one is F2 force, and both are inclined at an angle theta. Now these, and there is no external force you can see acting on that joint, then both the members will carry the zero force. How we can say this, that it is carrying zero force, both the members are carrying zero force? So we know that in truss, because all the joints are pin jointed or hinge joints, then at every joint there are two equilibrium conditions applicable, which is sigma fx equal to 0 and sigma fy equal to 0. So now by using our equilibrium conditions, we will see sigma fx equal to 0 means the summation of all the forces acting in x direction should be 0. So let's see. So in x direction, what are the forces acting? F2 and the component of F1 in the direction of F2 in the x direction. So it will be F2 and F1 cos theta. So it will be in the same direction. So it will be summation F2 plus F1 cos theta equals to 0. Suppose this is the equation 1. Now we have another equilibrium condition, which is sigma Fy equals to 0. Sigma Fy equal to 0 means the summation of all the forces or the component of forces in y direction should be equals to 0. So in the y direction there will be only one component of F1 sin theta, which is equals to 0. So whatever may be the theta is, it will be F1 equals to 0. If F1 is 0, just put this value in equation 1, we can find the F2 equals to 0. So by using these equilibrium conditions, we can say if at any joint there are two members connected and there is no external force or reaction acting at that joint, then both the members will carry zero force. Okay, this is our first thumb rule. What is the main condition here? Theta should not be 0 and theta should not be 180, because if theta will be 0, F1 and F2 will be acting in the same direction. Okay, so this condition will not be valid, and if theta equals to 180, then both the members will be collinear and in the opposite direction. The direction of forces will be in opposite. Okay, now the next thumb rule number 2. If at any joint there are three members connected, okay, among them two are collinear to each other and third one is in any direction. Okay, F1, like here you can see, in this two members are carrying F1 and F2 force which are collinear, and the third member is carrying some F3 force which is at an angle theta, and same here theta should not be 0 and 180 here. Okay, now in the third member it will carry zero force. F3 will be having zero force and F1 and F2 will be having the equal and alike force. How can we say this? Okay, again we will apply our equilibrium conditions. Sigma fx equal to 0. Sigma fx equal to 0 means the summation of forces acting in x direction should be 0. So here you can see F1 plus the component of F3 in the direction of F1, it will be F3 cos theta minus F2, because direction of F2 is opposite, minus F2 equals to 0. Let's take it as equation number 2. Now other equation, sigma Fy equal to 0 means the summation of forces or the component of forces in y direction should be 0. The algebraic sum should be 0. Let's see what are the forces. So there will be only one component of F3, that will be F3 sin theta equals to 0. So from here F3 will be 0. Once you have found out F3 is 0, just put this value in equation 2. If this will be 0, then you can see this F3 cos theta will be 0. So from here you can see, we can write that F1 minus F2 equals to 0. Now if F1 minus F2 is 0, then we can see F1 equals to F2, means the value and the nature of the both the forces, or you can say the forces in both the members which are collinear will be same and alike. Means both the members will carry equal and alike force. Means what? If one member is carrying the tensile force, the other member will also be having the tensile force. If other one is having the compression force, then the second member will also have the compression force. Okay. So this is thumb rule number 1 and thumb rule number 2. Now we will see one problem. How do we apply these thumb rules to identify the zero force members in any problem? Like here you can see one problem has been given to us. Okay, and you have to identify the zero force members in this problem. Okay, let us see. First of all, when we see, we have to see that if at any joint there are two members connecting and there should be no external force, or if there at any point there should be three members, among them two are collinear and third is in any direction, and there should not be any external force or reaction acting. Okay, let's talk about joint A. If there is 10 Newton force acting, then there will be some reaction, vertical reaction RA and RB, and there will be some horizontal reaction HA and HB. We are not finding it yet. We will see it in the next video when we will solve this problem. In this problem, we will see, in this video we will only see how to identify the zero forces. Okay, let's talk about joint C here. Okay, here you can see three members are connected, CE, CA and CD, in which CE and CA are collinear and CD is at any direction. It is perpendicular here, you can see, or it may be at any direction. So by our thumb rule number 2, if those two members are collinear and third member is in a direction, then the third member will carry the zero force. F3 will carry the zero force. Here we can see the CD will be having the zero force. Similarly, if we talk about joint K, again Ki and Kb are collinear members and Kj is in any direction, other direction. So Kj will be having the zero force. Similarly, if we talk about joint F, here you can see Fe and Fg are collinear, then Fd will be having the zero force. Similarly, if we talk about the joint H, okay, you can see Hi and Hg are collinear members and Hj is the third member acting at that joint. Okay, and there is no external force on that joint, so Hj will be having the zero force. Now by our thumb rule number 2, we have seen the CD, FD, Hj and Jk are having zero force. Now what are the other zero force members? See, now if we talk about the joint D here, let's see. Joint D is having members DC, DF, DG, DA and DE. But two members are already carrying the zero force. This means when we apply the equilibrium conditions at this joint, these members will have no effect. Obviously, because they are also already having the zero force. So we will see, because here DA and DG, these are collinear members, and D is in any direction and there is no external force or reaction acting at that joint, means DE will be having zero force too. I hope you are getting my point, because CD and DF, these are already having the zero force. So these members will not contribute in our equilibrium conditions, but it doesn't mean that we will remove these members. No, because it is important for our stability of the structures. Okay, we already know about the perfect truss and imperfect truss. Okay, similarly if we go to the joint J, here you can see the JB and JG are the collinear members and JH and JK are already having zero force member. This means these won't contribute in our equilibrium conditions. Okay, so JI will be having the zero force here. Is it clear till now? Okay, now what's next? Now in the next joint, which joint we should consider? Let's see. Now if we see, we talk about the joint I. Okay, in joint I you can see there are two members connected, IH and IK. Let's see, we do the FVD of joint I. So there are two members connected, IH and IK. Again here you can see two members are connecting because third is already having zero force, and there is no external force or reaction acting on that joint, then the IH will be having zero force and IK will also have the zero force. Is it clear to you? Now if we see at joint K, Ki and Kb are collinear members. So the force having Ki, which Ki will be having, it will be same in Kb. So it will also have the zero force. Similarly, if we talk about the joint H, Hi and Hg are collinear members. So if Hi is having zero force, so Hg will also have the zero force here. Okay. Now let's see. If we talk about the joint E here, at joint E you can see there is one horizontal force acting, but there is no vertical force acting. So if we will draw the free body diagram of joint E, what will happen? Let's see. There are three members connected. One is already having zero, so it will be only FEF. Okay, and a downward member will be having, suppose, FEC force. Okay, then 90 degree. So now if we will apply the equilibrium condition sigma Fy equal to 0, what will happen? Here you can see FEC, it will be equals to 0. If FEC is 0, then we can say that Ca will also have the zero force because both the members are collinear here. Okay, so how many number of zero force members are here? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 zero force members in this truss. Can you find any other zero force member here by applying our thumb rules number 1 and 2? No. These are the only 12 number of zero force members in this problem. Okay. So this video is all about to identify the zero force members in any truss. Okay. We will solve this problem in the next video. Thank you so much.